Good evening, class. I'm hoping that you have watched the vocabulary and found that there wasn't really anything new, just now we get to apply some of these things. First things first, when I look at something like this, right away I see two parallel lines. Now there's no name for these lines, I can't call them anything. But this top line that's horizontal has this arrow mark right here. The bottom line that's horizontal has this arrow mark here. Because of how they're labeled, these two lines are parallel. Then there's this line here that cuts through both, or intersects both. That's the transversal. So, those four postulates and theorems that I introduced just a little bit ago, they all had that requirement. Two parallel lines cut by a transversal. Now I know corresponding angles have to be congruent. Alternate interior angles have to be congruent. Alternate exterior angles have to be congruent. Consecutive interior angles have to be supplementary. So just looking at this picture, when I'm asked to find the unknown angle measures, and I got 7 of them, this really isn't that bad, because I know there's at least 2 or 3 of them that have to be congruent. First things first, what about angle, or this one right here, the 105 degree one, and angle 5? Those are corresponding angles. And because of the corresponding angles postulate, they have to be congruent. Therefore, measure of angle 5 is 105 degrees. Whoops, I actually started with measure of angle 2. But measure of angle 5 is 105 degrees. Now, there's 2 ways you could have got measure of angle 2. First, because I know the measure of angle 5 is 105 degrees, I could say, well, angle 5 and angle 2 are alternate interior angles. So alternate interior angles have to be congruent. Therefore, measure of angle 2 is 105 degrees. The other thing that I could have done is I could have looked at these 2 angles here and said, hey, these 2 angles are vertical angles. Angle 2 and this 105 degrees are vertical angles. Therefore, those 2 angles have to be congruent. Measure of angle 2 is 105 degrees. Either route, I get that they're both 105 degrees. Now that I have angle 2 and angle 5 figured out, I could choose the corresponding angles postulate again to get angle 2 being congruent to angle 6 to figure out angle 6. However, let's use alternate exterior angles. So 105 and 6 are alternate exterior angles because of their location. Alternate exterior angles are congruent, therefore measure of angle 6 is the same as 105 degrees, or measure of angle 6 is 105 degrees. Alright, at this point I know 2, 5, and 6. They're done. Now I need to get 1, 3, 4, or 7. The one that I had chosen was angle 3. What I was thinking was angle 3 and angle 5 are consecutive interior angles. So the CIA theorem says that angle 3 and angle 5 have to be supplementary, and if they're supplementary, the next domino that would fall after that is that their measures would add up to be 180. So measure of angle 3 plus measure of angle 5 equals 180. I'm actually using 2 reasons: the consecutive interior angles theorem and the definition of supplementary angles. I didn't just use one, I used both. Measure of angle 3 plus measure of angle 5, well, I know angle 5 is 105 degrees. So let's throw that in there. Oops. If I put 105 in here and then I subtract 105 from both sides, what I will get is 75 degrees. 75 plus 105 is 180 degrees. Yep, measure of angle 3 has to be supplementary with measure of angle 5. If you look, angle 2 and angle 3 are supplementary. Well, that's fine. Angle 2 and angle 3 are a linear pair. They're supposed to be supplementary according to the linear pair postulate. Angle 3 and angle 105 here, angle 3 and this 105 degrees, they're supplementary because 75 plus 105. Yeah, that has to be true. They're a linear pair. Again, linear pair postulate. If I look at angle 3 and angle 1 here, they're vertical angles. Vertical angles are congruent, which means they have the same measure. Measure of angle 1 is 75 degrees. At this point, I have my entire top intersection taken care of. I have 5 and 6 done, so I need to find either 4 or 7. Let's go with 4. There's 2 ways you could do this one. Angle 3 and angle 4 are alternate interior angles, so they have to be congruent. Or you could do angle 1 and angle 4 have to be congruent because they're corresponding angles. Either way, you get 75 degrees. And last but not least, you have angle 7. It's a vertical angle to angle 4. It's the corresponding angle to angle 3. Or it's the alternate exterior angle to angle 1. In any of those cases, it has to be congruent to those angles. And angle 1, 3, and 4 are all 75 degrees. So angle 7 also is 75 degrees. That was a lot, but there we go. That's how I would find all those angles. Note, there's 4 of them that are the same. Anytime you have 2 parallel lines intersected by a transversal, you're going to have 4 angles that are always going to be the same measure, and the other 4 being the supplementary angle measure, or a supplement to those ones. That's just the way the cookie crumbles. Example 2, they now have this here. It says find the value of x. So I look. First things I look for are my 2 parallel lines. It's these 2. I didn't exactly have a nice way to draw the arrow on this to draw that they are parallel. So what I sometimes did is I drew a ray underneath. It looks like they overlapped a little bit. These rays that are really close to the line aren't there, but this arrow marking these lines as parallel are. So these 2 ones that are off tilt to vertical are parallel. And then this one here is a transversal. Well, the only x I have is right here. Well, corresponding angles, that would be the corresponding angle here, I don't know anything about. Alternate interior angles, that's left blank. It's an interior angle, so it can't be alternate exterior angles. My only option left is the consecutive interior angles. And I don't know angle 4. But if I did find measure of angle 4, I've got it. So why not try and find measure of angle 4? Well, 85 degrees and angle 4, well, those are vertical angles because they're across this intersection. So measure of angle 4 has to be 85 degrees. No way around it. Now that I know measure of angle 4 is 85 degrees plus this 2x plus 5 degrees has to be 180. Consecutive interior angles have to be supplementary if the lines are parallel. So measure of angle 4 plus 2x plus 5 equals 180. Because I know measure of angle 4 is 85, let's plug it in. And now let's just simplify. Combine 85 and 5. Subtract 90 from both sides. And last but not least, you divide both sides by 2 to get x equals 45. That's the answer. Also, it is not 45 degrees because if you plug it back in, you're going to get degree to the degree. No. Answer is just x equals 45. Alright, same question, just different format. Again, you'll see the same exact lines here. They're still parallel, but this time we're given different information. They still want me to find the value of x, which is right here. However, alternate interior angle wise, I don't know angle 2. This is blank, so I'm probably not going to use consecutive interior angle. And corresponding angles is again left blank. My only option is alternate interior angles. Well, I don't know the measure of angle 2. However, these 2 angles here will form a linear pair. This one here, that's 35 degrees, and this angle here, that's angle 2. So 35 degrees plus measure of angle 2 equals 180. Subtract 35 from both sides, and I get measure of angle 2 to be 145 degrees. At this point, I know angle 2 is 145 degrees, and I know 7x plus 5 has to be congruent to that angle, which means they have to have the same measure. So measure of angle 2 equals 7x plus 5 degrees. And seeing I know what measure of angle 2 is, let's throw in 145 for it. And at this point, it's just solve for x. I have an equation, numbers, solve for x. The reasoning there are, again, the alternate interior angles, corresponding angles, consecutive interior. If you don't know these, this problem is impossible. But once you do, you can simplify it down to an algebra problem. Subtract 5 from both sides, you get 140 equals 7x. Divide by 7 to both sides, you get x to be 20. That's your answer. It's done. That's it. And now, we're going to be doing the same type of problem as before, but it's going to look a little different. When I look at this problem here, what I see is a trapezoid. One set of sides being parallel, one aren't. One set of opposite sides being parallel, one set of opposite sides not being parallel. So this is a trapezoid here. And I'm told that this here is 3y degrees, and this is 87 degrees. And they just want me to find the value of y. Well, you might be thinking, how does this relate? We were talking about parallel lines cut by a transversal. Well, my trained eye, I see two different sets of what I need. Here's two parallel lines, and here's transversal number 1. And here would be transversal number 2. We're not going to go into depth of looking at this one, but this would be my second transversal of my two parallel lines. What I'm going to do here is I'm going to just change this picture a little bit so that it looks like what I'm used to. So now I look. This part is looking strangely familiar. And if I get rid of the rest of my shape over here, all of a sudden I look and I say, wow, that's just the problem I've been doing. Two parallel lines cut by a transversal, and now I know what to do. And that's just as simple as taking this and basically covering up that right side so that way I can picture it as what I'm used to, what I need to look at. And at this point, I say 3y plus 87 equals 180. Oh yeah, 3y and 87 are on the interior of my parallel lines, and they're on the same side of the transversal, which means they're consecutive interior angles. And if I go back to my theorem, that means they have to be supplementary. And supplementary means they have to add up to be 180. So when I look at this problem here, now I know the next thing I have to do is just solve for y. So subtract 87 from both sides to get 3y equals 93. Divide both sides by 3, y equals 31. This problem is actually not that bad, but you've just got to look at it the right way. If you don't look at it in the way that I just showed you, you look at this problem, there's nothing that I've taught you that would say that those are necessarily supplementary until you get in the mindset of this picture. And then from there, it's just setting up the problem and solving. Yep, that's example 4.